Hey guys, welcome back again. This is the second video for Thursday, April 2nd. So take a look at this one. This one's actually be a little shorter than the last one. We're on page 435 and we're going to do a little bit more graphing. Hopefully you had a chance to do the marble activity on Desmos and see how these graphs can move around and stuff. What we're going to do in this lesson is kind of summarize those movements you saw in the marble activity. Looking at the parent function as rational function, right? We've said all year long that you can always make an XY table in order to see how a function looks. So if we start plugging in random x values, right? Let's plug in 1. If you plug in 1 for x to this function up here in the top right, you get 1. If you plug in 2, you get 1/2. If you plug in 10, you get 1/10. So you can kind of see as you plug in a bigger x value, you're going to get a bigger and smaller and smaller y value. 1/1's right there, 2 1/2's right there, 10 1/10 is smaller and smaller and smaller. You can see that's why we're kind of getting a horizontal asymptote. If I plug in 0 for x, undefined, that's what gives me my vertical asymptote here at x equals 0. All right. Now, let's go the other way. Now, in a lot of our applications, we didn't see negative x's, but we will here. -1 gives me -1. -2 gives me -1/2, right? So -1, -1's right there. -2, -1/2 is right there. So you can see these graphs, or this left side of the graph also approaches 0. It gets closer and closer. If I plug in -10, I get -1/10. So this left side branch is going to approach like that. Approach the horizontal asymptote to the left. Now, this is kind of unique, but if you look at the table, let's plug in something like 0.5 for x. Let's do -0.5. Now, you got a calculator. You can do that in calc if you want. 1 divided by -1.5, you should actually get -2, right? So -1/2, -2 is down there. This is where you can see why this thing continues approaching the vertical asymptote. If I plug in -0.1, I'm going to get -10. So you can see as this x value becomes a smaller and smaller decimal, the y value actually becomes bigger and bigger. That works the same for the positive values, right? If I plug in +1.0, I get +10. So +1.0, +10, that's why this piece is up going almost straight up like that. It approaches the vertical asymptote, and then it bends over to the right and approaches the horizontal asymptote out here. So remember, these guys always approach their asymptotes up, down, left, right, at all the extremes, and then my horizontal asymptote here is y equals 0. So that is the parent function for these graphs. That's the starting function we're always going to use when we sketch these graphs. And all we're going to do today, in the second video, is apply some transformations. So this should look very familiar. Now here's the thing. You have these on your word wall several times. You don't have to write this all down again. In fact, I wouldn't if I were you. There's our parent function, right? We have, this was 1 on the last screen, but now it's an a. We have the x in the denominator down here. We just threw the b's and the c's and the d's and the a in there to talk about the stretches and shrinks. The a and the b value, we're not going to do much with that when we graph them. I want you to be able to look at an a and b and know what's a vertical stretch or shrink, a horizontal stretch or shrink, or some kind of reflection. It all works the same. But when we graph these, we're going to focus more on this, right? That's a shift left and right. This thing here has been giving us our vertical asymptote. It's got a restriction, so it's a vertical asymptote. And we're going to focus on this. That's a vertical shift up and down. So the original horizontal asymptote is at y equals 0. When I start moving this graph up and down, I'm changing that vertical asymptote, that horizontal asymptote up and down. So A and B, you should be able to know. You should be able to tell me if it's a stretch, a shrink, or a flip. But to graph these, the key is messing around with the x minus c and the c value here, and then the d. C works the same. Positives go left, negatives go right for that c. Okay, so let me show you what I mean. This is in your book. Take a second and write this down. Or no, don't write this down. It's already done for you, but it's 15a. So you can see from this transformation, right, there's the original parent function. We put a +2 in there. That's a c value, so that's why this thing moves 2 to the left. You can look, the horizontal asymptote is still y equals 0. There wasn't a vertical shift up and down, so that didn't move. and all the vertical asymptote did was went over to x equals -2. So I added a few things down here. This is what the bottom of this page here is what I'm going to ask you to do in the next worksheet for this for the homework of this assignment. So the vertical asymptote here is because we have a shift left of 2. It's now x equals -2. The horizontal asymptote didn't change, so it's still y equals 0. Now the x-intercept is a little strange, but it's the same technique we did in the last problem, or in the last video notes. If I plug in 0 for y, I get that. Multiply both sides by x plus 2, you get 0 equals 1, and that's impossible. 0 can't equal 1. So when something weird like that happens, before we would say no solution, now we say no x-intercept or none. And that kind of makes sense. If you look at the graph, we have a horizontal asymptote at y equals 0. It's going to approach 0 there. It's going to approach 0 there, but it won't hit them. Therefore, it won't have an x-intercept. Y-intercept, plug in 0 for x. You can kind of do that in your head if you want. You get 0, 1/2, and that's why you have a point there on the graph at 0, 1/2. Okay. Domain and range now. We've worked on this a lot, but looking at the graph, the easiest way to do domain and range here, just looking at the graph. If I work left to right, this thing goes from -infinity. I'm going to try that again. The domain for this guy, there we go, is -infinity to the vertical asymptote at -2, and then union -2 to infinity. You got to skip over -2. It's a restriction, and it's where the vertical asymptote happens. Now my range, remember, range goes bottom to top. This graph goes down forever, so -infinity. But as it starts rising up, we have to skip over y equals 0, because that's where the horizontal asymptote is. Union 0 to infinity. I can't use brackets anywhere there because these domains and ranges are affected by the asymptotes, and in this graph I'm not hitting those asymptotes. All right. Let's take a second and try this one. Letter B. We're going to do this one together, and then you guys can try the next one on your own. The only thing I want you to see here is that the transformation is a little bit different. That -2 is next to the x value, so that's a left and a right, and it's moving me right 2. Left and right just affects the vertical asymptote, so it's x equals 2. That's the restriction from the denominator. There is no shift up and down, so the horizontal asymptote has stayed at y equals 0. Right? Actually, we'll label that down here. Y equals 0. The x-intercept, same as before. We plug in 0 for y. You might be able to see what happens here. If you plug in 0 for y, you get 1 over x minus 2. So on this one, we get another none for x-intercept. That won't happen every time. I just realized I spelled intercept wrong there. Don't worry about it. And then the y-intercept, plug in 0 for x, and you get 1 over -2, which is -1/2. Okay. So let's go back. We'll do domain and range in a second. Let's sketch what we know. We know the y-intercept is 0, -1/2. Okay. We know the vertical asymptote, the horizontal asymptote, we have sketched. Now, here's the next skill we should be able to do. We only have 1 point on this graph. That's not enough. Whenever you need more points on a graph, XY table is what you have to go to. Okay. We already plugged in 0 for x, and hold on 1 second, I gotta plug in here. We already plugged in 0 for x, and that gave us -1/2. So if you look down here, I kind of know that this one branch is down in that bottom left-hand corner. I want more points, so I'm gonna plug in +1. I can plug in +1, x equals 1 happens right there. If I plug that in, I'll get another good point. If I plug in 1 for x, I get 1 over -1, which is -1. So 1 -1's right there. I've got 2 points on this bottom left branch. I feel good about it being down there. Remember, these graphs have to approach the asymptotes everywhere. So here's a good little sketch. It's got a nice little bend to it. That's all we're looking for. Now, again, it can't be above that piece because it wouldn't pass the vertical line test. So I know this next piece, next branch of the graph has to be either up here or over there. The only way to figure that out is by plugging points in. So the vertical asymptote's at 2. X equals 2. I'm not going to plug 2 in. I'll probably plug in 3. If If I plug in 3 to f of x, I get 1 over 1, which is 1. So 3, 1 is my point right there. I'm feeling pretty confident the second branch is in the top right corner of this graph, but I'm going to double check. I'm going to plug in 4 as well. You can plug in 5, you can plug in 6, you can plug as many points as you want. 2 or 3 in every little region should be enough. If I plug in 4, I get 1 over 2, which can't reduce. So 4 1/2 is right there. And you can see this other branch is up here. Okay. So to graph these, you're going to do all your vertical asymptotes, horizontal asymptotes. You're going to do the x-intercept, the y-intercept. And if you need any more points, you're going to make a little table and plug some points in. I didn't like that first graph because it looked like it was touching the vertical asymptote. It looks like it was touching the horizontal asymptote. Okay, so that's a graph. Let's go back and do the domain and range. Domain and range is always easiest to do at the end, working left to right. We got to skip over my my vertical asymptote, and working up and down, I have to skip over my horizontal asymptote. So domain here goes negative infinity all the way. My vertical asymptote is at 2. So negative infinity to 2, union 2 to infinity. And then my range, working up and down, goes all the way down to negative infinity. Then I have to skip over the y value of 0, and then it goes up forever. So the range here is negative infinity to 0, union 0 to infinity. And that's a pretty good example of what you're going to have to be able to do on the homework for this section. Okay, let's try one more. Go ahead and try letter C. This is not the same letter C that's in your book. I changed it and added some things down below. So take a second, see if you can't figure out the transformations and the horizontal vertical asymptotes and some points. Pause the video and try it. Okay, so here's what you should have done. This actually has 2 transformations going on. This x minus 5 in the bottom is moving this thing right 5. The plus 3 out back is moving it up 3. The most important thing that does right now is it gives me my vertical asymptote and my horizontal asymptote. So my right 5 takes me, my vertical asymptote that started at x equals 0 takes me to that. X equals 5. Up 3 takes me here, which gives me a horizontal asymptote at y equals 3. All right, so nothing new there. If I plug in 0 for x, I'll give myself a little bit more space here. All right, I'm sorry, I misspoke. For the x-intercept, if I plug in 0 for y, I get that. 1 over x minus 5 plus 3. Right, so same technique, plug in 0 for y. Now if I clean this up a little bit, now I'm going to subtract the 3 over, so negative 3 equals 1 over x minus 5. And just like we did on the last fluency test, I'm going to multiply both sides by the denominator. So multiply by x minus 5 over 1, x minus 5 over 1. On this side, the x minus 5's go away, so I just have 1. On this other side, though, be careful. You have to distribute that negative 3 in. So you get negative 3x plus 15. So here I am going to have an x-intercept. This is an equation I can solve. And the last one, I get weird things like 0 equals 5 here. That's when you had no x-intercept. This does give me an x-intercept. If I subtract the 15 over, I get negative 14. If I divide both sides by negative 3, I get 14 thirds. So my x-intercept is 14 thirds, comma, 0. Now, that's an exact x-intercept. When we graph that, we have to realize that that's almost 5. All right. Y-intercept, plug in 0 for x. Y-intercepts, like I said, are usually a little easier. If you plug in 0 for x, you get 1 over negative 5 plus 3. Figure out if I can write that somewhere. So what you get up when we plug in 0 for x, you get negative 1/5. I'll do the work underneath it. You get negative 1/5. Negative 1/5 plus 3. That negative, if you did it like it was set up in the problem, would actually be in the bottom, right? So it would look like that. But remember that negative in a fraction can go out front, up top, or down low. So if you do some common denominator work here, you get this negative 1/5 plus 15 over 5. You get a y-intercept of 0, negative 14 over 5. All right? So again, we're going to get the exact y-intercept there. We're going to use the decimal approximation when we graph it. All right, so let's sketch a graph here. We have the x and y vertical and horizontal asymptotes in. The x-intercept was 14/3, comma 0. So that's almost 5, right about there. The y-intercept was 0, negative 14/5. That's almost negative 3, right? Just shy of negative 3. So that's right here. Oh, sorry. What did I do there? I did something wrong. Sorry, positive 14/5. I was doing that on purpose to make sure you guys were paying attention. Right? I'm not going to redo the whole video just because I made that one mistake. But look back down here. Negative 1/5 plus 15/5. That's positive 14/5. Not negative. My bad. But I knew something was wrong just by the graph, right? So if you ever see if your points don't line up, you can go back and check your work. So y-intercept of 14/5 is almost positive 3, which is going to make more sense in my graph here. Positive 3 is right there. All right. So my one branch is in this bottom left corner. So it's going to approach these asymptotes here, never touch them. And it's going to approach and start going down here. It's probably got a little bit more bend to it. So let's see if I can graph this. Probably looks more like this. And then starts going down like that. All right. These are nice and smooth, have nice smooth bends. It's kind of hard to graph this on the iPad. But that's what it looks like approximately. Now, I don't know where the other branch is, right? So that's when I need to make an XY table. Don't have to plug in a ton of points here, but you're probably going to have to at least plug in 1 or 2. Now, if I look over here, I want to know what's going on to the right of my vertical asymptote at 5. Best x value to plug in is 6. It's directly to the next whole number to the right of my vertical asymptote. If I plug in 6, I get 1 over 1, which is 1, plus 3, which is 4. So 6, 4 gives me a point right there. You could plug in 7, you could plug in 8, you could get a few more points. But I know that this other branch is going to be in this top right corner of my graph. All right. So there it is. If you need points, you're going to make a table. Use your vertical asymptotes, use your horizontal asymptotes, use your x and y intercepts to piece everything together. Okay. Domain and range works the same way. I'm going to do it in red here so it kind of stands out. All right. The domain, I have to skip over that vertical asymptote, was from negative infinity to 5, union 5 to infinity, right? And then the range, be careful, we move this up 3. So now we have to skip over that y value of 3. So this goes negative infinity to 3, union 3 to infinity. And there's my domain and range. So there's my domain and range. So that's it, right? Asymptotes, x-intercepts, y-intercepts, table if you need a few more points, and you can get a pretty good graph of these rational functions. So that's it. Your homework for this section is 27-2. It's a worksheet that's posted on Schoology. I will be posting an answer for this next week so you can check it, an answer key for this next week so you can check it. And that's it. I hope to see you guys at the Zoom meeting, and then